Hey, what's up you guys? It's Ilarian Garbuzo with you, and today we'll talk on word embeddings. Let's talk about it. Word embeddings is the collective name for a set of language modeling and feature learning techniques in natural language processing, NLP, where words or phrases from the vocabulary are mapped to vectors of real numbers. Conceptually, it involves a mathematical embedding from a space with many dimensions per word to a continuous vector space with a much lower dimension. Methods to generate this mapping include neural networks, dimensionality reduction on the word, co-occurrence metrics, probabilistic models, explainable knowledge base method, and explicit representation in terms of the context in which words appear. Word and phrase embeddings, when used as the underlying input representation, have been shown to boost the performance in natural language processing tasks such as syntactic parsing and sentiment analysis. In linguistics, word embeddings were discussed in the research area of distributional semantics. It aims to quantify and categorize semantic similarities between linguistic items based on their distributional properties in large samples of language data. The underlying idea that what is characterized by the company it keeps was popularized by Firth. The technique of representing words as vectors has roots in the 1960s with the development of the vector space model for information retrieval. Reducing the number of dimensions using singular value decomposition then led to the introduction of latent semantic analysis in the late 1980s. In 2000, Banjo provided in a series of papers the neural probabilistic language models to reduce the high dimensionality of words representations in context by learning a distributed representation for words. Word embeddings come in two different styles. One in which words are expressed as vectors of co-occurring words, and another in which words are expressed as vectors of linguistic contexts in which the words occur. Rovis and Sol published in Science how to use locally linear embedding (LLE) to discover representations of high-dimensional data structures. The area developed gradually and really took off after 2010, partly because important advances had been made since then on the quality of vectors and the training speed of the model. There are many branches and many research groups working on word embeddings. In 2013, a team at Google led by Thomas Mikolov created Word2Vec, a word embedding toolkit which can train vector space models faster than the previous approaches. Most new word embedding techniques rely on a neural network architecture instead of more traditional n-gram models and unsupervised learning. One of the main limitations of word embeddings, word vector space models in general, is that words with multiple meanings are conflated into a single representation, a single vector in the semantic space. In other words, polysemy and homonymy are not handled properly. For example, in the sentence "the club I tried yesterday was great," it is not clear if the term club is related to the word sense of a club sandwich, baseball club, clubhouse, golf club, or any other sense that club might have. The necessity to accommodate multiple meanings per word in different vectors, multi-sense embeddings, is the motivation for several contributions in natural language processing to split single-sense embeddings into multi-sense ones. Most approaches that produce multi-sense embeddings can be divided into two main categories for their word sense representation: unsupervised and knowledge-based. Based on word-to-vec skipgram, multi-sense skipgram performs word sense discrimination and embedding simultaneously, improving its training time while assuming a specific number of senses for each word. In the non-parametric multisense skipgram, this number can vary depending on each word. Combining the prior knowledge of lexical databases, WordNet, ConceptNet, BabbleNet, word embeddings, and word sense disambiguation, most suitable sense annotation labels word senses through an unsupervised and knowledge-based approach, considering a word's context in a predefined sliding window. Once the words are disambiguated, they can be used in a standard word embedding technique. So multi-sense embeddings are produced. Multi-sense architecture allows the disambiguation and annotation process to be performed recurrently in a self-improving manner. The use of multi-sense embeddings is known to improve performance in several NLP tasks, such as part of speech tagging, semantic relation identification, and semantic relatedness. However, tasks involving named entity recognition and sentiment analysis seem not to benefit from a multiple vector representation. Software for training and using word embeddings includes Thomas Mikolov's Word2Vec, Stanford University GloVe, Allen NLP's Elmo, FastText, Yansim, Indra, and Deep Learning 4G. Principal component analysis and T-distributed stochastic neighbor embedding are also both used to reduce the dimensionality of word vector spaces and visualize word embeddings and clusters. Thank you guys for watching my videos. If you like my videos, push the like buttons, press the like buttons, subscribe, and give me a comment. Where do you use word embeddings, and do you use natural language processing? Thank you. See you tomorrow.